by any chance, does anyone here happen to know the day of the week that they were born on? If you think you know your actual birthday, raise your hand. Okay, well, a few of you. Okay, how about you? What year, if I may?
88.
88, and the month?
February.
February what?
24th.
24th. Was that a Wednesday?
Yes.
Yes, good. Somebody else. What year?
47.
And 47, and the month?
July.
July what?
19th.
19th. Was that a Saturday?
Yes, it was.
Great. How about you, sir? What year? What year were you born?
1980.
1980, and the month?
June.
June what?
12th.
12th. Was that a Thursday?
I have no idea.
You know? Well, now you know. Actually, I come prepared for that. I brought along with me a book of calendars. Goes as far back into the past as 1800, because you never know. If you could both double check that. So for 1980, turn to the calendar with 1980. And you said it was June what? 12th. Was that a Thursday?
Yep.
I'll tell you what, as long as you have that book with you, do me a favor, turn to a year outside of the 1900s, either in the 1800s or way into the 2000s. That'll be a much greater challenge for me. What year would you like? Go ahead. 1811. Okay, and what month? March what? 23rd. Was that a Saturday?
Yes.
And it was cloudy, I think. All right. In this lecture, I want to teach you a skill that you will find both amazing and useful. The ability to figure out the day of the week of any date in history. Once you've mastered it, you'll be surprised how often you use it. We encounter dates almost every day of our lives, so this is a very useful skill to have. Also, it's fun to be able to determine the day of the week of your birthday and the birthdays of your friends, family, and historical events. Many holidays are defined by days of the week. For example, Labor Day, Election Day, Mother's Day, and Thanksgiving. The method I'm about to teach you has been around for many years, but I've adapted it for the 21st century. Let's start with the year 2000. Now, every year gets a code number, and I define the code number for 2000 to be 0. Okay? Next, we need a code for every day of the week. So the code numbers for Monday through Sunday are 1, 2, 3, 4, 5, 6, and Sunday is 7 or 0. This is easy to remember because by this code, Tuesday is Tuesday. The rest of the list is easy too, right? Monday is one day. Tuesday is Tuesday. Wednesday, if you put the W on your fingers, that gives you the 3. Thursday is Fours Day. Friday is 5 Day. Saturday is Sixer Day. And Sunday is 7 Day or None Day. On a tangent, it seems that many people do not learn in school anymore where the names of the days of the week come from. The custom of naming the days after the sun, the moon, and the 5 closest planets dates back to ancient Babylonia. Some of these days we see immediately, right? Sunday, Moon Day, and Saturn Day are easy to see. Other names are easier to see in French or Spanish. Mars becomes Mardi or Martes. Mercury is Mercredi or Miércoles. Jupiter is Jeudi or Jueves, and Venus is Vendredi or Viernes. Mars, Mercury, Jupiter, and Venus were also the names of Roman gods. Now, the English language has Germanic origins, and the early Germans renamed some of these days for Norse gods. So Mars became the god Tiv, and Mercury became Woden, Jupiter became Thor, and Venus became Freya. And that's how we come up with Tiv's Day, Woden's Day, Thor's Day, and Freya Day. You probably mention the days of the week every day of your life, so I thought you'd be interested to know where they come from. Now, there are also codes for every month of the year. These are a little trickier to remember. Here they are. 622-503-514-624. And to make matters worse, there's even an exception for January and February. In a leap year, January is 5 and February is 1. We subtract 1 from the 6 and the 2 because the year hasn't leaped yet. Now, I know what you're thinking. What do those numbers mean, and how am I supposed to remember them? All right, well, first of all, notice that there are only 7 possible code numbers, 0 through 6. And what they mean is this: months that have the same code number will start on the same day of the week. For example, notice that September and December both have a month code of 4. So in any given year, they will both start on the same day of the week. So if, for instance, if this year September 1st is a Saturday, then December 1st will also be a Saturday. On the other hand, the codes for September and June differ by 1. So in any given year, September will always start one day of the week later than June. So if this year June 1st is a Monday, then September 1st will be a Tuesday. If it's not a leap year, February and March have the same year code. So February 1st and March 1st will be the same day. That's because February normally has 28 days, which is a multiple of 7. And every 7 days the week repeats. But in a leap year, February is 1 and March is 2. And so because of that 29th day, March 1 will be 1 day later than February 1. I'll say more about where these numbers come from later, but first let's spend a few minutes to memorize the month codes. I'll give you 2 ways to learn them. Let's first apply the phonetic code that we just learned from the last lecture to turn all 12 numbers, 622, 503, 514, 624, into a sentence. Okay, so using their associated consonant sounds, we can create the sentence, Shannon will see me later January. If you're solving birth dates on paper and you want to create a cheat sheet for the month codes, then this sentence will do the trick. For March, the 3rd month, you'd simply look at the 3rd entry for its code number, which is 2. But if you want to figure out birth dates in your head, then it's better to have some kind of link between each month and its numbers. Here's what I use. Okay, January is 6. Now, January is also winter, and winter has 6 letters. That's how I remember that January is 6. February is 2. Well, February is the 2nd month, so that's easy to learn. March is 2. Think of March to the beat of the drum. April is 5. You could think of April or Fools, either of which has 5 letters. May is 0. If you're having a sandwich, you may want to hold the May-O, is how I remember that May is 0. For June, we might think of a June bug, and bug has 3 letters. Let's see, July is 5. In July, you might see a lot of fireworks in the sky. It's cheap, but you'll remember it. August is 1. Let's see. August, it begins with A. It's the first letter. Or you might have some A1 sauce on your grill. September is 4. You might think of fall. September is fall, and fall has 4 letters. October is 6. You might think of tricks or treats, both of which have 6 letters. Actually, tricks rhymes with 6. That's another way to learn that. November is 2. On Thanksgiving, you might have 2 pieces of turkey, turkey spelled with a 2, of course. And December is the last month of the year, and last has 4 letters. Again, these are my links. Your puns and mnemonics may vary. If you really want to learn how to do calendar calculations, then I strongly encourage you to take just 2 to 5 minutes and learn this list backwards and forwards with whatever mnemonics you want. Once you've done that, come back and I'll give you a short quiz. Okay, so here's the list. Go ahead and study it right now, please. Okay, are you done? Are you done studying? I'm going to give you a quiz now. Let's see. We know that 30 days hath September, April, June, and November. What are their month codes? Okay, so the code for September would be, let's see, September is fall, so that would be 4. April is what? April Fools is 5, so that would be 5. For June, we had what? A June bug. Good, that's 3 letters. And November, you've got those 2 pieces of turkey, so that would be 2. If it's not a leap year, then what are the codes for January, February, and March? Okay, now if you think of Shannon and use the phonetic code, you know Shannon would be 622, so you can get all 3 of those at once. That's if it's not a leap year. And if it is a leap year, then the codes for January and February are 1 less. They become 5 and 1. But the code for March stays the same. The only 2 months affected by the leap year are January and February. Perhaps on a leap year, for the phonetic sentence, you might replace Shannon with the name Aladdin. Once you memorize this code, you can easily figure out the day of the week for any date this year. Now, I don't know what year you're watching this, but for instructional purposes, let's start with the easiest year, 2000. Let's figure out the day of the week for January 1st, 2000. Now, to determine the day of the week for any year, we use the following simple formula. We take the month code plus the date plus the year code. Okay, so let's say for January 1st, 2000, the month code for January, well now let's see, 2000 is a leap year, so the month code for January is 5. Now it's January 1st, so we add 1 for the first, okay? And then the year code for 2000 is 0. Great. So we take 5 plus 1 plus 0 and get 6. We add those numbers together, we get 6. So January 1st, 2000 was day number 6, which is Sixer Day, Saturday. Okay, so January 1st, 2000 was Saturday. Here, let's do another example. How about July 4th, 2000? Okay, July has a month code of what? For the fiver works is 5, good. For July 4th, we simply add 4. And for 2000, we always add 0. 5 plus 4 plus 0 is 9. Now, what is day number 9? Now, you could count 1, 2, 3, 4, 5, 6, 7, then go around the corner for 8, 9, ending on Tuesday, but you don't have to do that because every 7 days, the week repeats. So you could subtract 7 from 9 to get 2 and land squarely on Tuesday that way. Okay, one more. Let's try December 25th, 2000. All right, so December has a month code of, it was the last month, 4. For the 25th, we add 25. And for 2000, we add 0. 4 plus 25 plus 0 is 29. What's day number 29? I don't know. Let's subtract the biggest multiple of 7 to make it smaller. Right? So what's the biggest multiple of 7 less than 29? That would be the number 28. Okay, so 29 minus 28 is 1, and 1 day is Monday. Okay, you can now figure out the day of the week for 2000. Good. The hard part is over. Okay, now how about 2001? Well, what normally happens to your birthday as you go from one year to the next? It usually bumps up by a day. Why? Well, since there are usually 365 days between your birthday, and 364 is a multiple of 7, 7 times 52 is 364. So if every year had 364 days in it, your birthday would be on the same day each year, and that would be pretty boring, and that's why they don't do it that way. All right, actually it has more to do with the earth and the sun. But anyway, with 365 days between your birthdays, it'll shift by 1 day, except when a leap year is involved, in which case your birthday could shift by 2 days. So, for the year 2001, all we do is change the year code from 0 to 1, and everything else stays the same. Okay, so for instance, December 25th, 2001, we'd add 4 for December, 25 for the 25th, and for 2001, we'd add 1. 4 plus 25 plus 1 is 30. Subtract 28 to get 2. So Christmas 2001 was on Tuesday. Okay? Let's look at the other years. So 2002 will have a year code of 2. And 2003 will have a year code of 3. Now what about 2004? 2004 is a leap year, so most birthdays will be bumped up by 2 days. As a result, we leap over the 4 to get 5. So the year code for 2004 will be 5. By the way, note that 2000 is a leap year, and leap years occur every 4 years after that, right? So that's 2000, 2004, 8, 12, 16, 20, going all the way up to 2096. All of those are leap years. Incidentally, 2100 is not a leap year, and I'll say more about that later. Okay, so if 2004 has a year code of 5, then 2005 has a year code of 6. And then the next year it's 7. But wait a second, since we're going to be subtracting 7s when we're done with this anyway, we can subtract 7 right now. We'll simplify this to be 0. So 2006 will have a year code of 0. All right, 2007 will have a year code of 1. And what about 2008? We leap over the 2 to get 3. Since 2008 was a leap year, we leapt over the 2, leapt over the 2 to get 3. All right, 2009 will be 4. The year 2010 will have a year code of 5. 2011 has a year code of 6. And 2012, that's another leap year, so we leap over the 7 to get 8. But let's simplify this number by subtracting 7. So the year 2012 will have a year code of 1. Continuing this pattern, here are the year codes for the next 30 years. Now, find the year code for the year that we're in right now. If it's 2012, the year code is 1. If it's 2013, the year code is 2, and so on. I'll wait. Got it? Congratulations. You now know how to determine the day of the week for any date this year. And you'll be able to use this skill for the rest of your life. All you have to do is update the year code each year, and everything else stays the same. The day of the week can always be found using the same rule. Take the month code plus the date plus the year code and reduce it by a multiple of 7. So let's look at the example March 14th, 2015. Okay, so that, by the way, is Pi Day, 31415. Okay, so how would we figure that out? Well, March 2, right? March has a code of 2, and 14th, we add 14, and for the year 2015, according to our chart, that has a year code of 4. Add those together, 2 plus 14 plus 4 is 20. What do we do now? Subtract the biggest multiple of 7, that's 14. 20 minus 14 is 6, and Sixer Day is Saturday, so Pi Day will be on Saturday. You can use this method to determine the dates of holidays like Thanksgiving, Labor Day, Mother's Day, and President's Day. Unfortunately, it does not give us the date of Easter Sunday, since that depends on the lunar calendar. Let's figure out the first Monday in September. That's Labor Day for the year 2015. Now, September has a month code of 4. 2015, we just saw, has a year code of 4. 4 plus 4 is 8. Subtracting 7 gives us 1. Now, to get Monday, which is 1 day, we need to add the number 0. So September 0 would be a Monday, but that date doesn't exist. So we add 7 to get September 7 as Labor Day in 2015. Before we figure out other years in the past and future, let me quickly show you where the month codes come from. Here they are again. Look at February and March. Now, if it's not a leap year, then there are 28 days between February 1st and March 1st, so they will begin on the same day, because 28 is a multiple of 7. So, if February has a month code of 2, then March should also have a month code of 2. Let's go from March to April. Okay? March has 31 days, which is 3 bigger than 28. So, April will always start 3 days later than March, right? So if March has a month code of 2, then April has a month code of 2 plus 3 more, which is 5. And since April has 30 days, which is 2 bigger than 28, 2 bigger than a multiple of 7, the month code for May would be 5 plus 2, which is 7. But since we subtract 7s, we simplify that to the number 0. So, once we choose the month code for January, then everything else is completely determined. And how did we choose the code for January? Well, in order for January 1st, 2000 to be a Saturday, we had to make January equal 5 for leap years. Once we did that, then everything else is forced. In the time remaining, I'd like to show you how to figure out the year code for yourself, so you can find any year on the chart we've been using. Instead of using the chart, we're going to do it in your head. We'll even go back in the past, including the distant past, to determine birthdays. First, let me show you the formula for determining the year code for any year from 2000 to 2099. Once we learn that, it's easy to get the year code for any year in the 1900s or 1800s. For dates in the 2000s, the year code is given by the formula years plus leaps minus multiples of 7. Let's determine the year code for the next year that'll be a perfect square, 2025, right? You can do that. 45 squared is 2025. From our chart, we see that it has a year code of 3. But let's figure it out in our head without using the chart. Okay, here's the formula. Years plus leaps minus multiples of 7. For the years, we just take the last 2 digits of the year. So for 2025, that would be 25. Now, now we're going to figure out the leaps. 2000 has a year code of 0. After that, the calendar will shift once for each year and once more for each leap year. So in 2025, the calendar will have shifted 25 times for each year, plus 1 more time for each leap year. How many leap years are there? From 2001 to 2025, there are 6 leap years, namely 2004, 8, 12, 16, 20, and 24. You can get that directly by taking 25, dividing it by 4, and getting 6 with a remainder of 1. Always ignore the remainder. That's 6 leap years after 2000. Okay, so the number of leap years is 6. So years is 25, the leaps is 6. Add those together, we get 31. And now what do? We subtract the biggest multiple of 7 that we can. The biggest multiple of 7 would be 28. 31 minus 28 is 3, and that's the year code. All right, that's the year code for 2025. Let's figure out the year code for 2076, the year of the U.S. tricentennial. Okay, so here the number of years would be 76. How many leap years? We take 76, divide it by 4, which is 19. So years plus leaps, 76 plus 19 is 95. Now what do? We subtract the biggest multiple of 7. Now if you know your big multiples of 7, you know that 91 is a multiple of 7. It's 7 times 13. And 95 minus 91 is 4. If you don't know your big multiples of 7, that's okay. Take that 95 and first subtract 70 to get 25. And now using 25, subtract the biggest multiple of 7, which is 21. 25 minus 21 is 4, and that's the year code for 2076. So on July 4th of that year, we'll have a year code of 4 for 2076. July is a 5, and the 4th of July would be a 4. So if we add 4 plus 5 plus 4, it's 13. Subtract 7 to get 6. So that day will be on a Saturday. Okay, we've got the future covered. Now what about days in the past? How about dates in the 1900s? As it turns out, January 1st, 1900 was a Monday. So 1900 will have a year code of 1. So everything in the 1900s gets shifted by 1. So for dates in the 1900s, the year code is given by the formula years plus leaps plus 1 minus multiples of 7. That's the only change. So for instance, since we know that the year 2076 has a year code of 4, then 1976 will have a year code of, just add 1, 5. All right, so if the 4th of July on 2076 was a Saturday, and the 4th of July on 1976 was a Sunday. The only exception is that January and February dates of the year 1900 are 2 days ahead of their corresponding dates in the year 2000, but that's the only exception. Let's determine the year code for 1961. That happens to be the most recent year that reads the same upside down. It also happens to be the year that Diana, the future Princess of Wales, was born. Okay, the year code for 1961, how do we get that? We start with the years, which is 61. Then we calculate the leaps. Take 61, divide it by 4. That's 15. Ignore the remainder. We've got 15. And since it's in the 1900s, we add 1 to it. 61 plus 15 plus 1 is 77. With that 77, what do? Subtract the biggest multiple of 7 to give you 77. 77 minus 77 is 0, so the year code for 1961 is 0. By the way, when I perform the birthday calculations, I always ask for the year first, since this is the hardest part of the calculation. I won't even ask for the month until I've figured out the year code. Once I have the year code, the rest is easy. So for Princess Diana, who was born on July 1st, I'd start with 1961, which we said has a year code of 0. And then July, I'll add 5. And for the 1st of July, I'll add 1 to get 6. And so she was born on day number 6, which is Saturday. Here's a shortcut that might come in handy when the year ends in a high number, like 1998 does. It can be shown that between 1901 and 2099, the calendar repeats every 28 years. You can see this pattern in our chart, since 2028 is a leap year with a year code of 0, just like 2000 was a leap year with a year code of 0. So if you don't want to deal with a big number like 1998, you could subtract any multiple of 28, 56, or 84, to make that number smaller, and the calendar will be exactly the same. So for instance, for 1998, we could subtract 84 to get 1914, and that's a much easier year to use. For the year 1972, you could subtract 56 to get the year 1916. Or you could add 28 to that to get the year 2000, which you already know has a year code of 0. Just as a reminder, this rule only works between the years 1901 and 2099, but it won't work if the 28-year period crosses 1900 or 2100 because those are not leap years. Let me say a few words about that. The rule is, for leap years, is that every 4 years is a leap year, with the exception that a year divisible by 100 is not a leap year. But there's an exception to the exception. If the year is divisible by 400, then it still is a leap year. So 1600 was a leap year, but 1700, 1800, and 1900 were not leap years. 2000 and 2400 are multiples of 400, so they are leap years, but 2100, 2200, and 2300 are not leap years, so you may want to plan ahead. Incidentally, here are the year codes for the recent centuries. Okay, 2000 has a year code of 0, 1900 has a year code of 1, 1800 is 3, 1700 is 5, 1600 is 0. So to determine a date in the 1800s, you would do years plus leaps plus 3 minus a multiple of 7. For the 1700s, you do years plus leaps plus 5 minus multiples of 7. For 1600s, it would be exactly the same as the 2000s. It would be years plus leaps minus the biggest multiple of 7. It can be shown that the calendar will repeat every 400 years. In other words, whatever day of the week it is today, it'll be the same day of the week 400 years from now. I could also say that whatever day it is today, it was the same day of the week 400 years ago, but we have to be careful since not all countries were on the same page 400 years ago. The calculations we've done all use the Gregorian calendar, which was established by Pope Gregory XIII and adopted by the Catholic countries in 1582. The Gregorian calendar was adopted by England and its colonies in 1752, and when they made the transition, 11 days were lost. Wednesday, September 2nd, was followed by Thursday, September 14th. It wasn't until the 1920s that all countries were on board. Prior to the Gregorian calendar, European countries used the Julian calendar, established by Julius Caesar in 46 BC. Under the Julian calendar, leap years happened every 4 years with no exceptions. But this created problems, since the Earth's orbit around the Sun is not exactly 365¼ days. It's about 11 minutes less than that. Sometimes people ask me the days of the week of ancient history, like what day of the week was January 1st in the year 0? The answer is none of the above, since prior to the 3rd century, most places did not have 7 days of the week. Instead, the situation was like what the Beatles once described as 8 days a week. If you spend a little bit of time practicing your calendar calculating, you'll be an expert in no time. You'll have opportunities to use this skill on, literally, a daily basis. I now recommend reviewing your multiplication and squaring, as well as the phonetic code, since in our next lecture, we plan to take those skills to a whole new level. Get ready to do problems that you never thought you could do in your head when we learn the techniques of advanced multiplication.